All right, we're going to continue with our discussion for chapter 4, polynomial functions of higher degrees. We're going to look at section 4.4, polynomial equations, inequalities, applications, and models. Polynomial equations and inequalities. The method for solving quadratic equations were known to ancient civilization. There's a little history here. 16th century mathematician derived formulas to solve third and fourth degree equation. In 1824, Norwegian mathematician Niels Henrik Abel proved it possible to find a formula to solve fifth degree equations. Also true for equations for degree greater than 5. So let's take a look at this example here. We want to solve x cubed plus 3x squared minus 4x minus 12 is equal to 0 using the zero product property. So let's take a look at this problem. So we have our equation in descending order. We let it be equal to 0. If it's not descending order, you can make it like that. We have x to the power of 3 plus 3x to the power of 2 minus 4x minus 12 equal to 0. Now, we can solve this by factoring if it's factorable. Now, in this case, it looks like we can factor by grouping. We have 4 terms. When you have 4 terms, they have nothing in common but one among these 4 terms. We can group the first 2 and the last 2 and see if that's the right grouping. Not always the first 2 and the last 2 would be a right grouping. Sometimes you may need to pick the first one and the third one, or first one or the last one and the middle 2 terms to see which would be a right grouping. But normally the first 2 and the last 2 should be a right grouping. So if I pick the first 2 here, group them like this, and then factor x squared out. As you can see, I have x squared times x plus 3. And then in the next 2 terms, if I factor a minus 4 out, you see we get x plus 3 here again. So that is a right grouping. Now I have x plus 3 in common among these 2 terms. So if I factor that, pretty much x plus 3 would be your greatest common factor. What times that give you the first term would give you x squared. What times the greatest common factor give you the second term, that would be minus 4. And as you can see, we can factor this even more. Here we have a difference of square. So that would be x minus 2 times x plus 2. So we get to factor this completely. Now I can solve for x. So the first solution would be x plus 3 is equal to 0. So x would be equal to negative 3. X minus 2 is equal to 0. And x plus 2 is equal to 0, we would get x equal to plus and minus 2. So our 3 solutions would be negative 3, plus 2, minus 3. And we basically using the factoring method to solve for x. So the solution set would be negative 3, negative 2, and 2 we can write it in brackets. So continue with part B. To graph this, we can enter the equation into our graphing calculator and it can confirm that the point of intersection, the graph would intercept x-axis at those points that we calculated, negative 3, negative 2, and also 2. Use the graph from part B to solve the inequality. Now, if this were greater or less than 0, then we can see the graph. If we go back to the graph here again, at what point your graph would be positive. So right between this is minus 1, minus 2, this is minus 3. From minus 3 to minus 2, you see your graph is positive, is above the 0, and so as right to the right of 2, your graph would be also positive. Your graph would be negative right in between negative 2 and 2, and also would be negative from negative infinity to negative 3. So by looking at this, you can see which side would be positive or negative. So your p of x would be greater than 0, like I showed you, from negative 3 to negative 2, and from 2 to infinity, and would be less than 0 from negative infinity to negative 3, and from negative 2 to 2. So we can easily verify that just by looking at the graph, which portion would be positive, which portion would be negative. Equation, quadratic in form. So when we have an equation is quadratic in form if it can be written as a, some factor a, times u squared plus b u plus c is equal to 0, where a is not equal to 0, because if it's a is equal to 0, then that won't be a second order equation, and u is an algebraic expression. So let's take a look at this example. We have x to the power 4 minus 6, x squared minus 40. We want to solve for this equation here. And we're going to find all the solutions. It could be a complex solution here. Here it says find all complex solutions here. So you give you a hint that you would get some complex solution here. So let's take a look. In this example here, we could use solve by substitution method here, because we have a fourth order equation. Because these two terms are square of one another, you could let x squared equal to another variable like w. That was how we used to solve that. Then we can see x to the power of 4 would be w squared. You could use substitution method here. So we could call this w squared minus 6w minus 40 to solve for w and go back and solve for x. But here what we really have is x to the power of 4, we call it x squared. That would be x to the power of 4. And as you can see, we can make that substitution here. We can call that x squared, here is called a t. You can call it anything you want. So if you call it t, that would be t squared minus 6t minus 40 is equal to 0. And this, we are forcing this to look like a second order equation basically. So we solve, this is factorable. So we solve for t. So t would be equal to 10 and t would be equal to negative 4. But we are not solving for t. Or if you let it be equal to w, then we would say w is equal to 10, w is equal to negative 4. We're not solving for that intermediate variable. We're solving for x. So we have to go back to our original assumption. We said x squared, in this case, is equal to t. So there are two situations we have to check. If t is equal to 10, and also if t is equal to negative 4, we have to find the corresponding value for x. So in this case, we have x squared is equal to t. So we have x squared is equal to 10. So x would be equal to plus and minus radical 10. And then if you have x squared is equal to negative 4, then x would be equal to plus and minus radical minus 4, which is equal to plus and minus radical 1 times radical 4. Remember, every time we see radical minus 1, we substitute that with I. So that would be plus and minus. This would be 2. So it would be plus or minus 2i. That's how you get x equal to plus or minus 2i. So these are the complex solutions. And we also get x equal to plus and minus radical 10. So the solution would be plus and minus radical 10 plus and minus 2i. So for part B, we want to see where p of x would be greater or equal to 0 or less than 0, given the endpoints of the interval in both exact and approximate forms. So if you look at the graph here, you can see your graph going to intercept at these points that you find. So above this line, the graph would be above x-axis, right from negative infinity all the way to this point, and also from this point all the way to positive infinity. The graph going to be below 0, right between these 2 points that you calculated. Exact value would be square root of plus and minus radical 10, or approximate value would be, if you put this in your calculator, would be about 3.16. So these are the point that we have: minus square root of 10, plus the square root of 10. So above this graph would be below 0, below this x-axis, less than 0, right in between these 2 points, negative radical 10, positive radical 10. And as you can see, we can write that solutions here. The graph is below the x-axis for these values, between negative radical 10 and positive radical 10, as I showed on the graph. These are exact values, forms, and approximate form would be use your calculator, radical 10 would be about 3.16. Find all solutions to each equation. In this case, we have 4x to the power 4 minus 5x to the power 2 minus 9 equal to 0. We can factor this. Here we have 4x to the power of 4. We could use trial and error method here. So x to the power of 4 would be x to the power of 2, x to the power of 2. The possibility for 4 would be 4 and 1. And for negative 9, you're looking for two numbers. When you multiply them together, you get 9. So it would be 1 and 9. If you multiply the two closest term and two furthest term, you get that middle term minus 5x squared. So we let each of these be equal to 0. 4x squared minus 9 equal to 0. In this case, we isolate x. We get 4x squared is equal to 9. X squared would be equal to 9 over 4. So x would be equal to plus and minus radical 9 over 4. So right here we get x is equal to plus and minus radical 9 over 4, which turns out to be plus and minus 3 over 2. And then for the other part, we have x squared plus 1. So in this case, we get x squared is equal to minus 1. As you can see, we get x squared equal to minus 1. X would be equal to plus and minus radical minus 1, which is equal to I, plus and minus I. So the solutions would be plus and minus 3 over 2, plus and minus I. If you look at this equation, you want to find all the solutions. We have 2x cubed plus 12 equal to 3x squared plus 8x. First step is to move everything, all the terms to one side of the equation. So I'm going to go ahead and subtract 3x squared and 8x to both sides of the equation. And then looks like we can use factor by grouping again. If I group the first two and the last two terms, you notice that you would x squared in common. If I factor x squared and minus 4, then you get 2x minus 3. So it looks like we get a right grouping here. So if I factor 2x squared minus 3, I would get x squared minus 4. All right, this is a difference of squares. So I can continue with that. I get x squared minus, I could write this as x minus 2 times x plus 2, and then factor that, and then solve them. All right, x squared minus 4 is equal to x squared is equal to 4. So x would be equal to plus and minus radical 4, which is equal to plus and minus 2. So we could actually write this as x minus 2 times x plus 2, and we get the same exact answer, of course. The second part would be 2x minus 3. So isolate x would be 2x equal to 3. So x would be equal to 3/2. So it looks like our solution set for this part would be plus and minus 2 and 3 over 2. Show that 2 is a solution of this equation, and then find all solution of this equation. So in order to show if 2 is a solution, we want to know if x minus 2 is a factor of that. So we can use a synthetic division. So I need to know if x minus 2 is a factor. If x minus 2 is a factor of this polynomial, that means then x would be the solution. If I solve this for x, x would be equal to 2. So if x equal to 2 is a solution, x minus 2 is a factor. In order to see if that's the case, then you can use synthetic division. If I divide x minus 2 into this polynomial, I should get the remainder of 0 if it is a factor. So if you recall, your k would be equal to 2 here. That's where you put the 2 down here. So that would be a good review of synthetic division. We bring the 1 down here. We multiply 2 times 1 and place them here, and you add them up, and you continue this process. 2 times 5 give you 10. We add them up, we get minus 1. 2 times minus 1 give you negative 2. And here we get the remainder to be equal to 0. We could evaluate P of 2. If I evaluate P of 2 and find that is equal to 0, that would also prove that the 2 is a solution, x minus 2 is a factor, using that remainder theorems that we discussed last time. By the factor theorems, x minus 2 is a factor of P of x. So I can write as x minus 2 as one of the factor. The other factor would be right here. We have 1 times x to the power of 2. The degree of this is 1 less than degree of this, what we have. So it would be, the quotient would be 1x to the power of 2 plus 5x minus 1. So this would be my other factor. Now, if this is not factorable, I can use quadratic formula now to solve for the rest of these. So in this case, one solution would be x equal to 2. And here it's not factorable, so I can use the quadratic formula. Minus b plus and minus b squared minus 4ac divided by 2a. So that would be my other two solutions here. So the solution would be 2, and one solution would be minus 5 plus radical 29 over 2. The other solution would be minus 5 minus radical 29 over 2. These are exact solutions here. So if you look at your graphing calculator, you can confirm these point of intersections as being approximately where the solution is. So minus 5 minus radical 29 over 2 and minus 5 plus radical 29 over 2. If you use your calculator, and you can see that would be the values around minus 5.19 and 0.19. And that's exactly what your calculator shows being the point of x-intercept. So let p of x be equal to is given as this. Use the graph of p to find p of x equal to 0, greater than 0, less than 0. So we can easily graph this using your calculator. And as you can see, the graph going to be above x-axis, right from this point here to this point, and also would be above x-axis right from this point to infinity, would be below x-axis from negative infinity to this point, and also would be below x-axis between these 2 points. And as you can see, that's how you can see where your graph going to be above x-axis or below x-axis just by looking at the graph and the point of x-intercepts. Solve the equation and inequality. So this is given to us as 2 times x squared minus 1 plus 2x times 2x minus 1 equal to 0. So in this case, I could distribute this. I get 2x squared minus 2. And then I'm going to distribute the 2x. You get 4x squared minus 2x. Combine like terms, I get total of 6x squared from 2x squared plus 2x, I get 6x squared. And then I'm going to write this in order. This is not factorable here, so I'm going to use quadratic formula again here. So if you use a quadratic formula, x would be equal to 1 plus and minus radical 13 over 6. I get 2 solutions here. So it would be the same equation less than 0. So you remember the point of intersection we find. If you look at the graph, you're going to see between its zeros, these are the points that you find. 1 plus radical 13 over 6, 1 minus radical 13 over 6. So the solution of inequality, that would be the intervals that we find. That would be 0 at this point here. This is where your graph going to intercept. And it shows here that the graph would be below 0 between these 2 points. Below 0 would be between these 2 points. From negative infinity to this point, and from this point to positive infinity, that would be above 0. So that's how you can see whether it would be below 0 or above 0 just by looking at the graph. Complex nth roots. If n is a positive integer, k, a non-zero complex number, then a solution of x to the power of n is equal to k is called an nth root of k. For example, minus 2i and plus 2i are square roots of minus 4, since plus and minus 2i squared is equal to negative 4. Negative 2 and 2 are 6 roots of 64, since plus and minus 2 to the power of 6 equal to 64. Complex nth root theorems. If n is a positive integer and k is a non-zero complex number, then the equation x to the power of n is equal to k has exactly n complex roots. Find all 6 complex 6 roots of 64. So here we have x to the power of 6 is equal to 64, and basically we're going to solve for x. So we have x to the power of 6 minus 64 is equal to 0. As you can see, this would be the difference of square. So if I can write this as something square minus something square, so this would be x to the power of, has to be 3 here. 2 times 3 is equal to 6. And here would be 8. 8 times 8 is 64. So my A is x to the power of 3 and my B is 8. So I can use the difference of a square. Remember, A squared minus B squared is equal to A minus B times A plus B. So my A is x to the power of 3 and my B is 8. So if I factor this, I get x to the power of 3 minus 8 times x to the power of 3 plus 8. Now these are difference of cubed. If you recall, if I have x to the power of 3 plus y to the power of 3, you factor this as x plus y. That would be x squared, y squared. The middle term would be xy. If this is plus, this term would be plus, and all the terms for the second parenthesis altered between plus and minus would be plus, minus, plus. And this was if I have x cubed minus y cubed, then that would be x minus y, and the terms would be exactly the same, except all the terms in the second parenthesis would be positive. You have to memorize these two formulas here. So there it is. Your first term is x, your second term is 2, because here is x squared minus 2, x cubed minus 2 cubed. So that would be x minus 2 times, using these two formulas, you get x squared plus 2x plus 4. And then from this one here, similarly, we get x plus 2 times x squared minus 2x plus 4. So now we can solve for this. X minus 2 is equal to 0. It means x equal to 2. X plus 2 is equal to 0. It means x equal to negative 2. And we can use the quadratic formula for this part here. For the first one, this is not factorable, so I have to use quadratic formula. My A is 1, and my B is 2, and my C is equal to 4. Everybody should know how to do quadratic formula by now. As you can see, get minus 12 here. Minus 12 is equal to square root of minus 1 times square root of 12. So if you get the square root of minus 12, that is the same as square root of minus 1 times square root of 12. Square root of minus 1 is equal to I, and this is 3 times 4. So part of this is perfectly square. So it would be 2 radical 3. So that's why you get 2i radical 3 for square root of minus 12. Okay, and then we do the same thing for the other part. You would get the answer. So you get one answer being minus 1 plus and minus I radical 3. The other two answers would be 1 plus and minus I radical 3. So we get two solutions here, We already had two solutions before, which were minus 2 and plus 2. And these are all our solutions for that polynomial we had. We have 1, 2, 3, 4, 5, 6 solution. That was a 6th order equation. So let's take a look at this application problem here. A box with an open top is to be constructed from a rectangular 12-inch by 20-inch. So here we mark this, that would be 12 is the width and the length is 20. So we have all this information we can put on the graph here. So that would be from a piece of cardboard by cutting equal size squares from each corner and folding up the side. So we are cutting x from each side. So as you can see, this would be 20 minus 2x, then this would be 20 minus 2x. And the width here would be 12 minus 2x. Okay, we have all the information we need here to solve for the first part. If x represents the length of the side of each square, it says determine a function v, that's a volume, that describes the volume of the box in terms of x. We know the formula for volume is length times width times height. So if you picture that, your height is x, and we already figured the length and the width is 12. The length is 20 minus 2x, and the width is 12 minus 2x. So the volume would be the product of the height, length, and width. So if I multiply this together, the formula that they're looking for, the equation for volume that they're looking for, would be 4x cubed minus 64x squared plus 240x. You also want to make sure that you write the restrictions here. We know that as shown, x must be positive, obviously. X has to be a positive number. That's a height. and then 20 minus 2x, this also has to be positive, and also 12 minus 2x also has to be positive. So this 12 minus 2x also has to be positive. When you solve for this, you would see that x has to be greater than 0 and less than 6. So this would be the restrictions that we have. So if you solve this 2, you would see that it has to be less than 6. So that would be my restrictions here for the size of x. So we can graph y1 and take a look at, if we want to show these windows here on your calculator so you can see the whole thing, and you would see that the intercept here, the graph is shown. So y1 is equal to this formula that we found with the crosses at the arbitrary choice 3.6. It's equal to that. So what that means is if you pick at x equal to 3.6, if I assume that the length x equal to 3.6, then the volume of the resulted box would be 221.184 cubic inches, just by looking at this figure using your calculator. When it says determine the value of x for which the volume of the box is maximized. So it's maximized means you're looking at the vertex. Okay, if you recall, if you look at your graph, or you can use that formula v of x minus v over 2a. But if you look at the highest point of the graph, use a calculator to find the maximum, local maximum point on the graph to the nearest hundredth. So the correspondence of the point would be 2.43, and here would be corresponding number to that would be 262.68. So what that means is if I let x equal to 2.43, then the volume would be the maximum volume would be this amount here. So when x is about 2.43 is a measure of the side of each cut, and then the volume of the box would be maximized to approximately 262.68 cubic inches. Here it says for what value of x is a volume equal to 200 cubic inches, greater than 200 cubic inches or less than. Again, you can see where would be the point of intersection for your graph and the y is equal to 200. And as you can see, these are the point of intersections here. And so above that would be between these 2 points. Below that would be from negative infinity to this point, and from this point here to positive infinity. So we can locate those points and figure out at what point your graph would be below or above those lines. This would be another example. The table shows the number of unit cells of the Apple iPhones whiteboard in millions for the selected years. So here we have in years 2010, that's the number they're giving us here, all the way to 2014. That would be the number of Apple iPhones sold. So we're going to use our calculator to use a regression to find a cubic polynomial p of x that models the data, where x represents the year after 2010, graph p, and the data together. So in this case, we want to let 0 be equal to 2010 when you enter the values into your calculator, and then 1 correspond to 2011, 2 correspond to 2012, and so on. And then please make sure you know how to use your calculator. If you're using TI calculator, there are tons of sessions already posted in class for using the right keys to enter the values into the calculator. And then when you get the regression line, this would be given to you on your calculator. This would be the coefficient of x cubed, x squared, x, and the constant. It was given to me. So, and this is what you should get on your calculator. And you can scatter plot the points here, and when you ask for the regression curve, And you can see the curve would nicely go through most of these lines here. The graph of P and the data are shown. Note that x equal to 0 represent 2010, x equal to 1 represent 2011, and so on, as we mentioned before. For part B, the year 2015, we kind of want to predict the number of the phone being sold. For 2015, that corresponds to 5 then, right? Because after 2010, so that would be 5 units after that. So if I evaluate P of 5, we can use our calculator to find P of 5 with the formula defined, and that gives you approximately 147.8 million units sold in 2015, which is lower than actual amount, 231.22 million. So that using a polynomial models to predict results outside the data set can be misleading sometimes in this case. As you can see, the graph of the cubic model past the value 4 shows that the function begins a downward turn, unlike the data which tends to go upward.